Hello everyone, welcome to today's Novedge webinar, Fast and Easy 3D Reverse Engineering with QuickSurface. Mesh to Surface will be presenting their latest product, QuickSurface, for converting 3D scan data to CAD models. QuickSurface is a complete reverse engineering solution that complements any 3D scanner which can export STL meshes or PTX point clouds. And our presenter today, Kostadin Vransalyev, is the product manager of QuickSurface, and he specializes in 3D scan processing, 3D scan algorithms, product design, and has more than 25 years of experience. He was also a key member of the team who built the first handheld 3D laser scanner. And now let me tell you a little bit about Novedge. Novedge is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, faster service, and no headaches. Check us out at novedge.com. And now we're even offering a workstation, and we custom make them. And since you don't want to, buy without trying, you can test drive them remotely. Just check novedge.com for details. And now, without further ado, I'm gonna switch screen so I can let Kostadin do all the talk. Take it away, Kostadin.
Yeah, let me just start my presentation first. Hello, everyone, and welcome to our webinar. Just briefly, thank you, Barbara, for introducing me. But to say a bit about our company, we are a Bulgarian company with a long experience in 3D scanning, and we participated in the development of the first handheld scanner. But we love processing data. Our team is built with the mathematicians and developers, primarily from the field of 3D scanning. And we are specialized of how to handle them, how to process them, and be able to visualize millions of points on screen, and most important, to get the most information from it. Before I start my presentations, I'd like to say a few words about the 3D reverse engineering and how do we understand this. The world has changed, and the 3D scanning arrived in our world, but before that, the people still were doing this. And the way they were doing is by using a ruler or just using some sketches, and they were reconstructing a CAD models. CAD industry is quite an old one, but the problem with this software is that they don't really understand what the meshes are. They cannot handle a large amount of points. It's difficult for them to manipulate. You cannot apply the Boolean operations, and all the processes cannot be applied on this type of meshes. So there is a need actually to use this information in a good way and put it into these CAD packages. So this is what we understand that reverse engineering is. It is not about creating a closed STL mesh and being able to print, but instead of that, we understand reverse engineering as converting this STL data into a useful CAD model. What is actually a correct reverse engineering? As you see on the left, there is a scan model of a watch, and on the right, mathematically, both of the results are valid. They are CAD models of the physical object. But which one is useful and how it can be used for your processes? As you see on the top, this is automatically served, probably, and it's with a huge amount of data. And if you want to trim or apply a Boolean operation on this object, you can experience how difficult this is. The bottom right is actually what the user expects to see. It has parametric information such as radius of the cylinder. You have a symmetry, and so you can build exact model. Why we focus on our products and why we want to build them? Back in my time when I was a product manager of the scanner, we were seeing people that look at our demonstrations and they see the scanned result on the screen and they think that this is a ready cut model, and it was hard to explain to them that this is okay for printing. You can take this and apply some tools on it, but it's not what you actually can use in your cut package. As you see in this example, there are some imperfections. This is some noisy data. So definitely this is not what the cut package understands. And also, I would like to say that reverse engineering, converting this into a proper cut model, it's really difficult. And there is no universal solution. I meet different people with different needs, and every project is unique. You need to apply different approaches. You need to use different strategies in order to get the desired result. And also, it is very time-consuming. What we try to do with our products is actually to help the user to shorten this path and be able to generate the results in an easier way. Where do we place our product? We want to bridge the needs between the scanners, which you see on the left, and being able to pass this information to the next products in the chain. Our ultimate goal is only to serve this conversion. We don't want to create a CAM package, or we don't want to create a simulation, but just to be able to convert this and pass this in the chain. On the left side, you can see a different type of scanners, from the long-range scanners to the micro scanners, where they can scan a size of a coin, or the new CT scanners, they can scan even smaller objects. And we try to handle all this information, be able to convert it into a CAD model. The workflow is quite simple. You load an STL mesh from the CAD model from the scanner. You put it in our software, you generate with the different strategies your model, and then you export. I would say we are not the only one player on the market, and there are other solutions. And quite often people say, why QuickSurface? Well, what is so special? Well, I would like to say that we have some unique features which I would like to show you today. But also we cover all the standard tools for the user to be able to create the full model, such as 2D and 3D sketching. We provide dimensioning, solver in the 2D. But one of the key features we have is that we have automatic surfacing, quite powerful tool. We provide also a manual freeform modeling, which is also quite unique. Also, we provide a real-time control, which is one of our key features, because when you create a reverse engineering, you need to actually be able to control your results. You need to compromise between the accuracy and the design intent. So at the end, you save time, you save resources and money. So this is on the screen. You can see some of the features which we provide in our software. And finally, before I move to the technical demonstrations, I would like to say that we have two editions of the software. One is the full version of QuickSurface, which provides all the tools necessary to convert the model, to convert the scan data into a solid model or surface model, and be able to pass to the other CAD packages. But we also have another version which is called Freeform edition, which is dedicated only to be able to provide freeform surfacing. The reason for doing this is because some of the applications, people already have solution how to generate prismatic shape. They just can measure them or take them with a tactile measurements, or with a ruler, or in a different way. But the problem comes that they cannot handle, or they cannot capture the freeform surfaces where the shape is quite difficult to be reproduced. And now we are moving to the technical demonstration, where I would like to show you the software. Unfortunately, I don't think we can fit in this 1 hour to show you everything that we have in our software, but I would like to emphasize and to speak more about the tools that are unique for QuickSurface and where our strength is. So, as you see on our screen, QuickSurface is a standalone application which runs on Windows only at the moment. So I'm not sure that we'll have any plans to run this on Mac. But the way you start, you have a 3D view where you just open an STL file which comes from a 3D scanner. This is the file formats we support are STL and OBJ, and also for the long-range scanners, the PTX point clouds, because this is an ordered point cloud and we can triangulate. When you open the file in QuickSurface, in this case, it's a STL. We don't know about the units, so you can adjust, the user can control in which units this file has been saved, and you put it in this 3D view. We support 3D mouse, so the user can navigate and see the object on the screen. Here is the time just to mention that we don't have at the moment any mesh editing tools. I would like to say this, that we don't have this on purpose, because back 20 years ago, all the scanner manufacturers, they were just throwing the scan data out from their scanning devices, and they were relying on other software to process them, to close holes, smooth, sharpen the mesh, and get the result like you see on the screen. But nowadays, this is not the case, because every scanner manufacturer focuses to create as good as possible a closed, watertight mesh. And if this is not the case, it actually will be really soon. And that's why we don't want really to focus on providing tools to the user that they already get for free with their 3D scanner. So you rotate this, you can explore your object on the screen. And of course, the dream of everyone is to just press a button, and which we have here, which is called Auto Surface, and then press start and then get the result on the screen. I must say that although it's not a 5 minutes work, regardless of the complexity of the object, it takes about a minute. But this is our auto surfacing. You don't need to do anything. You just press the button and you got your results. And this is what you have now. It is your surface ready. I didn't do anything. I just pressed one button and get my results. So the next step, of course, would be, let's take a look at how good we are. We have a compare to. At any point, you can just explore how close your surface is to your scan data. And as I always say in my presentation, it's about the accuracy, how close you want to be to your scan data. In this case, in this demonstration, I work with the 50 microns accuracy, so you can see what's going on. The next step, you just press export, and we can export in IGES or step file format. You can press save, and it's stored on the disk. Then in this demonstration, I'll use SolidWorks, but we are not limited to SolidWorks only. You can use any CAD package, because IGES and STEP are a common standard CAD industry file format. We put this here. We can take a look about the quality. It is continuous G2 everywhere, and you can apply any Boolean operations on this object, and you can use it for other purposes. So let's get back to QuickSurface. Unfortunately, despite the fact that Auto Surface is one of the best on the market at the moment, it is not a perfect, it's not a magic. So there are many cases where this is not good enough, but the good thing is that our Auto Surface is fully editable. You can go back, you can adjust, and you can apply different deformations to your result. You can manipulate your results, so it's not a static result. So this is the part where our auto surface is. But let me start with another example, which is very simple part that we'll go through other features of the software. I always start my presentation with this prismatic shape, which is contained. It's a really simple one. It contains a couple of cylinders and planes, but it's good for people to understand the process of what's going on. If we get any scan data, normally they come arbitrary in space. They are not aligned. If I just switch on my coordinates system display, you see that this object just floats in space, and it's not what we need. In order to be able to apply correct reverse engineering, it's always that it's good that the part is aligned. QuickSurface provides aligned tools that you can visually tweak your position of the object on this in space, but that's not the right solution. I would like to introduce you our tools, which is called the mesh selection. And this is an important part for our workflow, because most of the primitives which we extract are based on the triangles which we mark. So QuickSurface provides a couple of tools to mark triangles which can be used for different purposes, for example, to define a primitive. And in this case, I just use my magic wand, which is a curvature-based selection tool. You just pick a triangle, and then using your slider, you just get your desired triangles. And then we have a lot of tools here to do some manual selection. Using an Alt key, you can remove selection, etc. I will just unselect everything, and we'll just show you one interesting tool which we also have. And this is if you have a huge part and you want to focus just on a small particular area, you can just select and isolate this part of your object, and then you can save this as an area. And then you can just show everything. You can pick another part, and then you can isolate again or create an area where you want to work, and then you can save this in another area. The good thing is that you can save this in the file, and later on, if you just double click, and you just will be applied, and you can come and focus on this area, and you can do what you need. But let's get back to where we started and do something that we want for the next steps. What I want in this case is just to take some areas and define my primitives. I can just select area here, which in this case is plane, and then I can use my primitives menu and define my primitive. We support 4 types of basic primitives like plane, cylinder, cone, and sphere. In this case, I'll just create my best plane and press OK. The next step would be just to create this cylinder using the mesh selection again, pick this. There is a shortcut where you can just feed the primitives from the context menu using the right mouse click, and I create my cylinder. Okay, it takes a while because the algorithm. So we got our cylinder here, and it's the best fit. And the next step would be actually to create another plane, which is on the front plane, which I will need. And I will just use the plane fitting. And this is what we created here. We created 3 primitives here. And the good thing in QuickSurface is that these are not static. You can just pick, you get the handles on the screen, and you can adjust the size of these primitives. You don't need to play with this coefficient about how many percent they need to be larger or smaller. You can always do this interactively on the screen. So the way we align an object is just using our align tool. And how it works, I'll just pick my bottom plane, and I just tell the software that this is my bottom. And everything is aligned, but only to the level which is defined, which in this case means that my plane, the only condition I provided is that the plane needs to be coincident with my global OXY plane. Next step would be I'll take the cylinder, and I just say that this is my z-axis, and then I can just take my plane, and I will tell that this is my left axis. So what happened now is that actually our object is in the correct position in space, and I can start my reverse engineering. While we are here, I would like to move to the next step and how to create a body out of these primitives. I will just probably rotate this a little bit, and they just self-intersect here. So the next step, for example, would be how can I reconstruct my surface here? And for these purposes, we have something which is called trim operation. The trim operation in QuickSurface is mutual trimming. If you are familiar with the cut packages, we don't use a master cutting tool or secondary surfaces that needs to be trimmed. It's simply everything is trimmed, and then the way you need to reconstruct your result is just by clicking, and then you tell the software which parts needs to be removed. But I will just reset for now the trim, and I will use our automatic trimming command, which actually uses all the information which is available in underneath from the scan data, intelligently using some parameters, searches for the neighborhood, and it, as you see, it just creates our body automatically. As you see, this is our first result, and we can move further. This was about the positioning of the object in space, and I would like now to speak a little bit about 2D sketching in QuickSurface. I just load this artifact. We don't have time to physically go through the whole process of reconstructing this, so I'll use this only to show you some of the tools which we have. The 2D sketch is a tool which actually creates a cross-section from the object, and then you can use this cross-section as a reference to reconstruct your profiles for the purposes of extrusion or revolved surfaces. There are different options which, if you look at our tutorials, you can learn, but now I will just go through some of them. You can navigate and define the way your section works. You can define the surface to the section plane to be on a common planes, but also you can refer to other primitives. For example, I will just on purpose create a plane which is somewhere in space here, and we'll create the plane. I can use this as a reference now by using when I use the 2D sketch, I can just select that my cutting plane will be parallel starting from my reference plane, and then I can move and pick my section here. But for the purposes we need to go through now, we don't need this. I will just take my section here. One option I would like to mention is that for some applications, if you have parts, it might be quite useful to use the outline mesh functionality, which actually will not go as a sections through the mesh, but will take all the data and we will outline the results. As you see, this is our sketch which we generated using our outline tool. In 2D sketch, what is interesting about our software is our auto sketcher, which is a time-saving tool. The way it works is there are two different ways. You can use the spline approximation through the contours, or you can use the line arcs extraction. It's not a fully automatic, but the user also is allowed to help the software. As you see here, the red marked areas will be defined as lines, but the user can actually paint and help the software. With using the Alt key, you can remove some of the selections, so the software knows that this will be lines and arcs here. I can just paint here and tell that this is also line here. And then you can just preview your results, and the software automatically extracts, and if you see, it optimizes using the reference section to get your curved trimmed fillet here. And if you're happy with the result, you can just press accept. Then this is a valid sketch entities which you can edit. For example, it failed here. You can just select, and you can use your extraction tool, where you can just paint and select your areas, and you define how this needs to be fit. In this case, I want this to be a circle, and then you can go back. For example, here, if I want to reconstruct this area, it will be hard for me to select only the areas which will define the circle, so I can use my brush tool. I can just paint a little bit here, and then I can fit a circle. Again, I can continue using the other selection to define a line, and I will just select something more here, and then I'll create another line. When I'm happy, I will go back and will continue my work. What we provide here, which is available in other packages, but also for us, it's a time-consuming saver. It's the trimmer, where you can just trim quickly with the power trim. And then what you can do also is our fillet operation, where you can interactively generate your fillets just by creating these tangent arcs here. We also provide a solver where you can actually create dimensions. You can define your numeric values to define exact numbers for these primitives in this case. So this is basically what we use for 2D sketching. I would like to create another sketch here, which is for the extrusion, so I can show you a bit more, and I will create this surface here. I will just quickly, using the Shift key, I can mark, and the software will automatically create my extracted arcs in this case. And I can create a tangent arc between them. We're not limited only to 2 lines. But the good thing is that we have something which is a tolerance analyzer, which means that anytime when you define whatever you do, as you see on the screen in real time, it just actually measures how close you are, and this helps you to get the most accurate results. So when you're ready, you get your sketch, and the next step actually would be to create an extrusion from this. For the purposes of modeling, sometimes I'll just hide this sketch because I don't need it. For the modeling, we need to actually navigate, use this extruded surface and come to this face here. But one option is just to fit a plane, but this is too time consuming. So what I can do is actually select this area, which is my planar area. And then I can just edit my extruded surface. The reason I'm editing, because I have my bottom plane here, as you see, and then my top plane, which I can play with. But we have something here which is optimized to the selected point. Because I selected my reference plane, I can just tell the software, please put my bottom plane to my selection point, and then I press OK. So now if I just compare the result, you see that I got quite close to the surface. The next step, the next feature, which is quite new and I'd like to show you, is the fit surface command. The fit surface works on the selection, so it expects that you get some points which you want to define the surface. I definitely see in this case that this is a plane here, so I don't really need this. I selected the other part, which it's hard for me to model. It's probably a loft or a different surface, so I just selected this. I probably can improve. I just see that it select through, it's enabled, so I have to make sure that I don't have other selection in this case. So this is the area I selected. probably I need to remove something here. It doesn't need to be accurate, but I'm ready to go now. I just press OK. And then I call my fit surface command. The fit surface command approximates the desired surface, and it starts with a 10 by 10 control point. We have tolerance display, of course, to see how close you are to the surface, and you can play with the software, the smoothness of your result, so you can compromise. In this case, you can get much smoother result, or you can get quite close to the surface. Also, you can adjust the orientation. The orientation in this case is taken from the best fit of the plane, but you can also make it axis aligned. So in some cases, it's just perfectly aligned to the global coordinate axis. You can also define how much it needs to be expanded for the purposes of trimming later on. But also what we have is here is the auto button. So if you use this function, you tell the software how close you want to be to the data. Of course, because QuickSurface is designed to work with the noisy data, you need to be careful what this target should be. We don't recommend this to be 1 micron, but you can put this value to the specification which you have taken from the scanner. Normally, this type of scanner, they are about 50 microns. When you press OK, the software automatically starts adjusting and finds the number of points which are within tolerance. So the maximum resolution you can go to is 50 by 50. In this case, it found that it's a 90 by 90 control point. But if you play with the smoothness, you see that we get out of the tolerance. And if I run auto, it will go much higher in terms of number of control points. So when you're happy with this, you just press OK, and you got your surface. Of course, all these surfaces are fully compatible for the trimming. You can just select and apply a trim operation. I just remove and press OK. So this is my result. At any point, you can just press compare, and you see how close you are with the surface. I just applied smooth here. The good thing is you can always come. That's why it's a parametric modeling. You can come and you can change your intention, your parameters. You press OK, and everything is reconstructed. So now you can get completely different results. So this is what we understand about parametric modeling. So this is about the sketching. We will move forward about our complex mechanical results, which I would like to show you, which you can reconstruct with these traditional approaches. You can do cuttings and trimmings, and from objects like this one, you can end up to the object like this one. Also, another example is this watch, where we used a lot of tools to apply the trim operations and booleans, and to get these results. We also support patterns here. I want to show that just a few words about the Boolean operations. If we model this solid body, at some point, let me show you the starting object. It's this one. We created this cylinder here in the center, and also we modeled this cylinder on the top of the object. And so far, we created this solid body. What QuickSurface also offers is not only a surface modeling, but also the solid modeling. And I'll show you what I mean with this. I'll take this cylinder and I'll actually create a circular pattern in this case. For the circular pattern, it uses the z-axis by default, which is not what I need. But even if I use the y-axis, I see that it's not what I expect. So in this case, we can use the reference of my cylinder 1. which makes exactly what I need. And in this case, I have 5 instances. I can always preview. And then the good thing is that we support Boolean operations. We can choose this main body, and we want to apply the cut from this body. I just pick this cylinder, and I can pick any of the instances here, and they will be applied, so I can get this result. The Boolean operation approach is quite powerful because you can always come later and you can do more complex modifications. For example, in this case, if I explore this cylinder, it's with the radius 1.5, but we can easily make it 1.4. And then when you apply OK, everything will be reconstructed. So this is the parametric modeling and the mechanical part of modeling of QuickSurface. Now I'm going to move to our Freeform modeling tool. If we take an object like this one, as you see, it's quite noisy. It's badly scanned. I know the modern scanners, they provide much more accurate data. This particular one was made by me a couple of years ago. As you see, the quality of the mesh is not perfect. But let's see what we can do with this. The goal of this is, I reconstructed it before the presentation, is to come to these results. And how we can achieve this, we need to explore and see our tools. So what we have in QuickSurface is called Freeform QuickSurface modeling. And the way it works, it uses quotes, actually. You start with a single rectangle, and then you actually expand until you generate your results. There is a duplicate handle where you can just take and put it on the object. There is a mode which is called snap mode, which helps us, whatever we do, that the points just belong and are projected back to the mesh. And I just take these and manually we'll just create a couple of patches here. There is a D sign here in the middle of the edge, which tells us that this is a duplicate handle. I just do this and continue my work until I get some results. We move this edge and it's automatically merged. I can just take this and drag it on top of the surface, like this one. And this is how we reconstruct. In cases like when we have 3 sides here, we can just select on edge, right-click, and split this. And now I can easily close this to get my surface correct. So in this case, we have nice and smooth surfaces. They are G2 continuous everywhere. But the problem now is how good are we in terms of quality, how close we are to the surface. So you can start manipulating your object, but because of this snap to mesh technology, which we have, we always keep it on the surface. Also, we have something which is a real-time deviation analyzer, which means that if you just manipulate the points on the screen, they will get snapped on the mesh. In this case, what I can do is actually increase probably the resolution. You can use increase resolution, and then at any point you can just manipulate and get your results here as close as possible. It really depends on your design intent. But furthermore, in this case, I want this to make it symmetrical. We support also symmetry. And if I selected this plane to be my symmetry plane, I can see that everything is symmetrical. So whatever I do, it just applied on the other side. But now the problem is what happens here in the middle. I can just double click to select the whole chain and tell the software that this is on the symmetry plane. So whatever I do here, it always stays in the middle, and it's snap. Here we get a G2 continuity, so it's always smooth enough, as you can see, and you can get this transition. QuickSurface provides different tools, which we call the crease edge, to be able to create these edges as sharp edges. For example, you just double click and then you select that this is a crease. When it's a crease, then you can see that there is a sharp edge here, and here we have a G1 continuity. Excuse me. So we move to the next step about auto surface. We started this presentation with auto surface, and I'm not going to run through all the demonstrations, but just to show you a couple of results that we get, quite complex. And this is one example which has been auto surfaced. It's a large mesh, and then you can see that it's being converted into a cut model just with the hit of a button. This is nerve surfaces which can be exported. Or this is also another example of the surface which has been created just with the auto surface button. But the question now is how we can apply this auto surface. Can this help us for the mechanical designs? This is one example which we have here, like this one. And the way it works, we just press auto surface, and the user can play with the different parameters here. One of them is how many quads you expect to have at the end. Roughly, what do you want, more or less? And then you provide feature details. How complex is your object? If it was like the data I showed before, you probably go to highest feature details. In this case, it's just balanced, and then you press preview. When you apply this operation, again, it takes a while, but it doesn't take 5 or 10 minutes. It just takes about a minute until it generates the underlying surfaces. The thing about QuickSurface is that we don't export every individual quad as a surface, but we merge them into a larger surfaces, which for the purposes of processing in other packages helps a lot because it reduces the time for applying the Boolean operations. Okay, this takes a bit longer because it's a bit more complex, probably. But I hope it will make it soon. I would like to say that this is not the most powerful computer. It's just a normal i7 laptop. Okay.
While we're waiting, Kasadin, can I
Yes.
ask a question that we were submitted?
Yes.
Okay. Do you have something similar that can be used in the AAC industry with point clouds?
Can you repeat the question? I'm not sure if I
Yes.
understood.
Do you have something similar that can be used in the architecture and construction industry, but with point clouds?
Well, if the point clouds can be exported as PTX files, then yes, they can be used. While we're talking, I can try to find such data, an example. But since I spoke with some of our potential customers, they check if their long-range scanners, if they export in PTX file format. Once they can export in PTX file format, then yes, we can we can use this data. And I'll try to quickly to open such an example. This is a long-range scanner. You can apply some filtering before you import, and depending on the file format, how it is stored, you see this is data which comes from a long-range scanner. This is a single scan, but in this example, they can be many files. In this case, I'll see, I think it's there about 5 or 10. Yes, so this is a typical example which comes from a long-range scanner. And what you can do, you can apply the similar tools. You can just select, and then you can fit the primitives here, like a cylinder in this case, and you can just reconstruct this. I don't know if this is the right answer to the question, but I hope it is.
It's very cool. Thank you. Let us know, Nader, if that's the right question, the right answer.
Okay, I'll just go back to what I plan to do. I need to find my next file, just and I would like to show you about how we can use these auto surfaces in a more powerful way. And this is what we call the hybrid modeling. And we go to the data where we were. The good thing about freeform surfacing is that it can be combined in a way that you reconstruct object like this one, where it's hard to reconstruct these parts in a traditional way, but you can use only a freeform surface. And this is one example that you come up with this one. So also, I want to show another example is this object, where I'm not going to focus. I prepared my solid body before the presentation. So with the traditional extrusion and extractions, we created this body. But the question now is how can we proceed with this situation? And what QuickSurface offers, you just pick this area using the magic slider. You get the area which is defines your surface here. But also in this case, I need to apply a bit more selection. So I help the software to apply properly automatic surfacing. I select this visually. And then when I'm ready, I will just go for automatic surfacing. In this demonstration, I just use lower number of quotes so we can get a better, faster results. So the reason I'm doing this is that I want to show you how we can combine the traditional planes and extrusion surfaces with this more complex surface. It's nearly ready. And this is our results. Of course, you can play with the resolution, you can play with the accuracy here to get a better result, but I'm happy with this now. So what I need to do is just come to this edit surface. Again, like I said, auto surface is not a static, it can be edited. And here I will use our extrapolate command, which means you just take this edge and you extend it. Why I did this? Because I need to apply trimming. And in this case, I have my solid body here. And the next step, what I need to do is just take both and go for trimming. And here, again, I will use my automatic trimming because this will help me a lot. We have indicator on the top right that tells us what the end result will be of the trimming, which also helps you to get the right decisions. And as you see, we got this perfectly ready. I will just hide my mesh, and this is my hybrid model, which can be exported and be used in the other packages. And more or less, I covered more of the general functionality of QuickSurface. Unfortunately, there is not enough time to go through every detail, so you can see a lot of videos on YouTube, or you can visit our website. We also provide tools such as 3D sketching, loft sweeping, pipe. And the last thing I would like to show you is about how we communicate with other packages. And this is about our technology called QS Connect. The idea behind this is that even if we export the surfaces as a step on IGS, this is not good enough to get this into the other packages because people want to get the parametric model there. For example, in this case, I have this sketch, and the user, they need this sketch. In our case, I will just use SolidWorks. I'll just put them side by side so you can see. The idea for us for this transfer is that we communicate with the SolidWorks, but we pause if there are any issue with the SolidWorks so the user can go fix this and continue. And in this simple example, I just press start. What the software will do, it connects using the API of SolidWorks. It will reconstruct the sketch. There will transfer all this information. I don't know why it's not as fast as it's supposed to be. It reconstructs everything. It uses the COM technologies, the SolidWorks API, and it then will actually create a sketch and literally will create another revolved surface in SolidWorks. I hope so. I don't know what is the reason for this, but yeah, that's my sketch here. And this is my revolved surface. So now the idea is that currently the difference between this export and the QS Connect is that we have parametric transfer here, so the user can come and modify and create dimensions here and continue his work in SolidWorks. Another last example is that if we have a more complex part like this one, for example, I can also transfer everything to SolidWorks by using the export to SolidWorks command. And in this case, because I have a trim command here, we reconstructed the cylinder, we reconstructed the revolved surface. But then, as you see, it fails in SolidWorks, so I can go here, repair my result. I can just use my manual tools. Then I can select to create a solid, press OK, and then I can continue. Now the software will actually transfer in the fillet also, and I can see that I can come and edit my fillet. And instead of this being edit feature, instead of this being 0.5 millimeters, I can just change it. And I just demonstrate here that we don't transfer a static information from one software to another, but just to transfer all the knowledge which has been created in QuickSurface into SolidWorks. And this is the end of my presentation. Unfortunately, 1 hour is not enough to go through all the details. So now, please go with the questions.
Absolutely, thank you. So many great functions and so little time. One question is there a Creo 3 transfer capability?
Sorry?
Yes. Is there a Creo 3 transfer capability? Does it transfer to Creo 3?
At the moment, we connect only with the SolidWorks. We're working to build partnership with the other packages, but it takes a while until we get there.
All right. And David was just saying that he would love to see an auto front fender example. I don't know if you have one, prepared, but just, I think it's a curiosity.
A fender.
Yes, of automobile.
We probably have something similar. Okay. Are there any other questions?
Yes, one more. In the auto surface cup holder example, what if there's some data missing? Does the surfacing resolve that?
Good question. That's the power of QuickSurface is not a magic auto surface. And if I just take a sheet metal like this one, and then I just create my auto surface, you can always get back and finish off your work because it's a fully editable surface. That's make it different. It's not a static. Sometimes people, I press auto surface, I take this in my software and I finish the job. No, as you see now, this is not the perfect result. So I press OK, but it did, I don't know how many % of what I needed to do. So I can come here and I can finish my work. I can improve, I can probably investigate the results. I can probably increase the resolution here, like this one. So this is the freeform and auto surface, they go really together. So that's the power of this solution.
Cool. Cool. Yeah, that was it for questions. Oh, wait, just another question pop up. On this example, what if you didn't want those holes?
It works. Oops, sorry. Auto surface works on select. Well, if you don't want these holes, then you need to manually close them. You're right. You need to edit these and actually close them manually and close these gaps. And then you can apply the cut operation. But in this particular example, I strategically, what I would do is just I will use the extender like this one, because this gives me the result in space. This is my mesh. Then I technically will, let me just try to show you. I will just take this, will outline my mesh. And here I will just use my brush tool and we'll create 2 cylinders actually. And then this is another one. I'll feed a circle. And this is my extruded surface now. I will just create extrusion like this one. And then, because auto surface is a normal surface, I can just take these and I didn't prepare the other hole, so I can just use the trim command here, which actually I will just cut this. And as you see, I created this here. I intentionally clicked on the other part to get the perfect trim, and I get my results. So it's all about the strategy. What do you want to achieve? Why you don't want to have a hole here? Technically, I wanted a hole, but this is what I wanted to do. And of course, I can go now, edit, and I can give a dimension to this hole and make it 4 millimeters, or 4.5 in this case, and everything will be rebuilt.
Thanks for the amazing problem solving, and quick too.
The fender, this is what we have. I haven't tested really. This is the question.
Yep.
So I don't know. Again, auto surface is probably one of the best we have at the moment, but it's not a magic. You see here.
Yeah.
So probably if you play with the resolution, and this is what you get.
Well, thank you. Yeah, close enough. Hope that, gave you an example of the potential of QuickSurface. Well, that was great. I think, yeah, there's a lot of great feedback for you and for the presentation, and questions are all done. Kostadin, I will take the screen back just quickly so I can show everybody where they can go and find QuickSurface on the Novedge page. This is where you can find QuickSurface, novedge.com. Novedge is changing the way designers purchase 3D software. We have, first of all the choices, the freedom for you to go back and forth with different solutions, and we help you over the phone if you need it. So check us out on novedge.com. I also want to remind you that we also have powerful CAD workstation that you can completely create custom for you. We build them from scratch, and you tell us what you want and you can test them remotely. It's actually really cool. And today's presentation it's being recorded and will be posted on YouTube and Vimeo channels. I know some of you wanted to share with friends and colleagues. This is, is going to be uploaded on YouTube and Vimeo in a couple of hours. Thanks again for joining us today, Constantine. That was amazing. We're very excited to carry QuickSurface. Come check it out and have a great rest of the day, everybody. Bye-bye.
Thank you.